So we have here a first image where you can see what are they asking here in this image. Trace A and trace B. Best describe the kinetics of what events. So what they are asking is, we have two traces A and B, and they are asking what type of transport is happening in A and what type of transport is happening in B. Okay, so on the in the x-axis, what do you have in the x-axis? In the x-axis, we have the concentration of the molecule. In the y-axis, we have the rate of diffusion or rate of transport of the particular molecule. So you see trace A and trace B. If you look at trace B, how is it? It is a linear curve. Okay, whereas trace B is not linear. Okay, trace B is non-linear. It has a plateau. A plateau phase is present in trace A, whereas trace B is linear. So if you, by looking at both the traces, it is very clearly seen, or easily you can identify trace B is for simple diffusion. Trace B is for simple diffusion. Okay, whereas trace A is the trace for a carrier mediated transport. Okay. This carrier mediated transport could be an active transport or facilitated diffusion. It could be anything. So, to put in simple words, they can ask you, the options could be given in any ways. Trace A is a carrier mediated transport, trace B is a simple diffusion, or they can also give a trace B as a passive transport, trace A as an active transport. Okay, so whatever it is, when you look at how did I identify that trace B is simple diffusion and trace A is a carrier mediated transport. So, if you look at trace B, it is having a linear relationship. So as the concentration of the submolecule increases, the rate of diffusion is also linearly increasing. So that is a typical of this characteristics is typical of a simple diffusion. In simple diffusion, there is a linear relationship. Okay. Now, if you look at our trace A, what is happening? As the concentration of the molecule increase, as the concentration of the molecule is increasing, we can see that the rate of diffusion also keeps increasing, but only up to a certain point. Once it has reached the V max, okay, once it has reached the V max, then what is happening? There is no more further increase in transport of the molecule. Okay, so such type of transport happens when there is a carrier that is involved. So any carrier mediated transport will have a plateau phase. It will be limited by a Vmax. So by looking at the curve itself, we can identify that whether it is a simple diffusion or whether it is a carrier mediated diffusion. Once I have delineated that it is a carrier mediated diffusion, it could be an active transport or it could be a facilitated diffusion. Okay, so that is by identifying A and B. So A is nothing but the rate of diffusion by a carrier mediated transport. Okay, and B is simple diffusion, A is carrier mediated transport. So another characteristic feature what you can find from this particular graph, we can see that at any given point of time, though simple diffusion has a linear relationship, the amount of molecule transported is much less compared to a carrier mediated transport. Look at trace B. Uh, let's draw a graph here. Okay, let us take this as a point. Okay, so a particular concentration, um, at a particular concentration, let us call it as X. At a particular concentration of this molecule, look at the rate of diffusion. Look at the rate of diffusion for simple diffusion. It is very, very small. The rate of diffusion is very less. Whereas, look at the same concentration, for the same concentration of the substance, look at the rate of diffusion for the carrier mediated transport. That is, for carrier mediated transport, the rate of diffusion is far much higher for the same concentration of the molecule. That means what it is telling is, in case of simple diffusion, it has a slower rate of diffusion. The total quantity of solutes transport is much lesser in case of simple diffusion, whereas in case of facilitated diffusion, okay, let us take it as facilitated diffusion. In the case of a carrier mediated transport, in case of a carrier mediated transport like facilitated diffusion, though it is limited by Vmax. Vmax means that is the maximum that it can transport. That is, once all the carrier protein which is transporting that particular substance is saturated, no more transfer of substances will happen. No more transport of substances going to happen. So that is called as Vmax. That is called as, this type of transport is limited by Vmax, although it is limited by Vmax. Okay, but the amount of substance transported via a carrier mediated transport process is far much higher compared to the transport process of simple diffusion. So that is what from this graph we can understand these two concepts. Okay, so questions can usually come, you ask questions can be asked, identify trace A and B, or what do you understand from trace A and trace B, or they can also ask in which among these two the transport is going to be faster. So any type of questions can come from this. Whatever be the questions, now that you have a clear understanding of the graph, you will be able to answer any of this. Okay. So the total quantity of solutes transported is less in simple diffusion compared to that of facilitated diffusion, though simple diffusion is not limited by a Vmax. In simple diffusion, the rate of diffusion is slower compared to a carrier mediated transport. Okay. Now, what are the factors that determines the rate of diffusion? What are the factors that determines the rate of diffusion? There are we can divide these factors that determine the rate of diffusion into two factors. One is those factors or properties of the membrane. Other one is property of the substance that needs to be transported. Okay, so what are all the properties of the membrane? Properties of the cell membrane through which the particular substance has to transport. There are, for when we are talking about cell membrane, there are only two important factors that we have to take into account. One is the thickness of the membrane, another is the cross-sectional area of the membrane, that is the surface area of the membrane. Surface area is directly proportional. Okay, so the rate of diffusion is directly proportional to the surface area, and it is inversely proportional to the thickness. Okay, greater the thickness of the membrane, slower is going to be the rate of diffusion. Okay, greater the surface area, faster is going to be the diffusion. So surface area has a direct relationship, and thickness has a inversely proportional relationship when it is coming to the rate of diffusion. Now that is pertaining to the membrane through which the substance needs to be transported. Now there are certain properties pertaining to the substance that is transported as well. So what are those things? First and most important is the molecular weight of the substance. Molecular weight of the substance. Okay, if the molecular weight of the substance is more, then the rate of diffusion is going to be less. Okay, now just by remembering this molecular weight, I have two substances, so two ions that needs to be transported, sodium ion, potassium ion, and the molecular weight of sodium is 23. The molecular weight of potassium is 39. Okay, the molecular weight of sodium is 23, the molecular weight of potassium is 39. Now you tell me which among these two ions is going to be transported easily across the cell membrane. Is it the sodium or is it the potassium? Obviously, by looking only at the molecular weight, we would come to a conclusion that it is the sodium which will be easily transported across the cell membrane. But in reality, it is the potassium ion with a molecular weight of 39 which is easily are transported or easily passing through the cell membrane. Why? Because we are not just simply looking at the molecular weight, we will also look at the size of the molecule, in hydrated state. Okay, this is a very important concept. So we also have to look at the size of the molecule in its hydrated state. When hydrated, sodium is when hydrated, potassium is 500 times more permeable than sodium. Okay. When hydrated, so please remember, we don't just look at the molecular weight of the substance, we also look at the size of the substance when it is hydrated. So when hydrated, the size of sodium increases, whereas though the molecular weight of potassium is more, the hydration is less. So potassium is almost 500 times more permeable than sodium in its hydrated state. Okay, that is why potassium is more permeable than sodium, though the molecular weight of potassium is higher than that of sodium. Okay, so among those property which determines the rate of diffusion, one is the molecular weight and size of the particle when it is hydrated. Next is lipid solubility. We all know anything that is lipid soluble is going to cross through the cell membrane very easily. So the rate of diffusion is going to be higher. Temperature, increase in temperature is going to increase the rate of diffusion. Electrochemical gradient, when we are talking about electrochemical gradient, we'll divide it into electrical and chemical gradient. We all know this. Let us first talk about electrical gradient. Okay, electrical gradient, we all know the inside of the cell membrane is negative compared to the outside of the cell membrane. So it will be easier. Electrical gradient means it will be easier for a cation. It will be easier for a cation to enter the cell compared to an anion. Okay. Similarly, it will be easier for the anion to leave the cell compared to a cation, because from a region of higher concentration to region of lower concentration, same concept. Now, chemical gradient is, let us talk about sodium and potassium. So, in the ECF, sodium ion is more. Okay. So, what will happen? Along the concentration gradient. So it is from the region of higher concentration to a region of lower concentration. So automatically sodium will be able to enter the cell, diffuse into the cell easily compared to potassium. So that is called as electrochemical gradient. So electrical gradient is whatever charges, depending upon the charges. Chemical gradient is depending upon the concentration of the substance with respect to the inside and outside of the cell, where it is going to come from higher concentration to lower concentration. So it will be easier for sodium to enter into the cell. The rate of diffusion for sodium will be better while it is entering into the cell. The rate of diffusion for potassium will be better when it is trying to leave the cell. Okay. Now coming to the distribution, and finally charge we already told. And now coming to the distribution of the channels. So distribution of the channels depends upon the number of channels. If we have a lot of potassium channels, then the rate of diffusion is going to be more. So it is directly proportional. So these are all the factors that is going to affect the rate of diffusion. So by just giving this one graph, they can ask many questions. One is identify. Simply, they could ask a direct question, identify traces A and B. Or they can say, among these two traces, which is a faster transport. Third, they can also ask the properties. Okay, so any of these can be asked from this graph. Okay, and they can also, from this, they can mark a Vmax and ask what is Vmax. Okay, or anything pertaining to carrier mediated properties of a carrier mediated transport. Just they will mark Vmax here and they can ask you what are all the properties of this type of transport. It is any carrier mediated transport will follow saturation kinetics, as I already told you in the morning session. It is going to follow competitive inhibition. Okay, fine. So many questions are possible, and don't worry, be very confident that we have discussed most of them here.